So previously here, we were talking about, we were doing this where they were mapping and seeing if the map resulted in a function. Okay. And the thing that I had left undone was doing visually from a graph, sets of ordered pairs, from a written description, and from equations. So let's dive into this. So remember back here, we were saying how to tell if something is a function. So we started with tables. Then we did maps. Okay. This went pretty well today. Kids seem to understand. So now we need to do visually from a graph. So now we have to look at a graph and say if something is a function. All right, so this is going to be like the vertical line test. Let me zoom in here. Go away. All right, so this is new. And I just need to see what letter we're at. B, so the next one's C. So this is visually, or from a graph, graphically. We'll call it, we'll call it visually from a graph. How about that? I'm on the right density here. Visually from a graph. Okay. What do I want to say about this? Visually. Okay, so that's C sub point 1. We need to talk about the vertical line test. Okay. Oh, that's ugly. The vertical line test. What is the vertical line test? Well, we should define it. Okay, so this is little a. If what on earth? If you draw a vertical line and it passes through the graph at only one point, then the graph represents a function. Okay. So here we should make only 1 point red. Okay. Here's when you got to do an example now. Okay, so we can do shapes here. So we should do an example. Example. And we'll draw the graph here. And what I want to do is what I want to try to do anyway. Well, I guess first I'll do it simple so the kids can draw it. Okay, here's an example. And we'll say Y and X. All right, and let's do something easy. We'll say this is Y equals, wait. Is this graph a function? Okay, and so we have here okay, let me do this. Get the ruler in here. Is this graph a function? Well, yes it is. So we'll see if they get that. Okay, you apply the vertical line test and see. Now we'll do another example. I mean, you don't have to do that many to get this point across. This is pretty easy. And then here's an example. Is this graph a function? All right, now we need one that fails the test, right? Okay, so we'll do this. And come on. Okay, so now I want to draw I know. I'll subvert their expectations. So they expect there to be one that isn't a function. So I'll do one that is. Right. First, let's put some points down. Let me see how this looks. Oh, I don't know. That looks a little bit too confusing because there's an argument to be made there. Do it this way. Some crazy looking graph there. All right. Do another example. Whoa, what's going on? Oh, I need to write example. Duh. Okay, something's going on with my pen. I don't know what it is, honestly. It's weird. See that? It's weird. Is this graph a function? And now we got to do one that is not a function. Oh, this is too far to the right. Darn it. This needs to go over. Okay. And as I'm doing this, I'll explain that, this worked pretty well today. The concern I had was it was taking kids a long time to just write this down. And I don't know if I should really be making the students copy down everything I'm writing. It kind of defeats the purpose in a way. Why would I make these notes if I'm going to have the kids just copy them down? Shouldn't I just write them in person? I don't know. I have no idea. So here, because it kind of worked. I mean, it seemed like the kids were learning, but at the same time, it took so long to write everything down. I feel like we missed an opportunity to do more practice because we were spending all of our time writing this down. But maybe, and I could be wrong here, but in my opinion, writing it all down is part of the process of learning, right? So you have to write it down, I think. I mean, I really don't know because, I could give them these notes. And I do give them these notes, but having them physically write it down, that's the question. Does that matter? And I don't know. So here, let me do this. Let's do this. right. And then we'll do... The hard thing is I have a hard time remembering how I learned it. You know, that's the hard part, is I can't remember. How did I learn it? And I can tell you I certainly didn't learn it by... I certainly didn't learn it off a tablet, you know. So we're kind of in uncharted waters on whether this is a good idea, honestly. So what I'm trying to draw here is like a quadratic, but on its side. We'll see. So that'll fail the vertical line test, and we should do circles. So this is some stuff I was doing in geometry using these notes. So let me just put this stuff out of here. Got to extend down this line. Okay. I know one thing I was going to do is I was going to time myself writing this stuff down so I could see. Okay, so here's I was asking some students about should we do homework or not. So students saying you gotta have to have a little bit of homework, maybe flashcards, spend one class period dedicating to doing a free-for-all problems, and we do it, finish up the lesson, we can see what we're struggling. All my decision, workload, what's our responsibility, passing the STAR test, they'll thank me for the extra practice. Okay. That was good. That was good. I'll just say thank you for thank you for this good advice. For this thoughtful advice. Okay. All right. All right, and then I got another response. Second option for some of the kids that don't get it right away. Okay, so what another student said is I had thrown out the option of instead of having homework, we do a second day, like we do learning the lesson, we do like notes and then practice. Okay, notes, practice. There seems to be like a good pattern to that where if today was notes, then tomorrow is practice. So tomorrow we could practice what we've learned so far about functions instead of just continuing to take notes ad nauseum and never pausing to actually practice. So tomorrow I would do an in-class assignment where the kids practiced and they got a grade for it. And that would be like instead of homework. Okay, well, it's good stuff. We'll say very good ideas. Thanks to both of you. Okay, so some good kids giving me some good advice. I mean, I should take it, right? Okay. That's one thing about being a teacher. Everybody has advice. Now, the thing is, we don't ever listen to the students, and, they're affected the most by it. So I tried to ask some students, what did they think about homework? And did they think that it was really helpful or kind of superfluous? I honestly don't know. You think you have it figured out, and then nobody does the homework, and so you think, well, why am I assigning it? And the kids hate you, and the parents hate you, and it's like, well, okay. But then if you take the homework off, then the standards fall. So you don't want standards to fall. Like, that's important. You got to have the high standards, but how do you do that without assigning homework? I mean, it's like an intractable problem. I think the reason there's a big debate about it is because no one really knows what to do, honestly. Okay, so there are some limit cases here. On the I need to look something up here. So we're going to do the circle next. So this is going to be the circle. So what I got from that interaction was flashcards, yes, and then maybe not homework, but maybe a little bit, and also having a day where we do a summative day. See, the reason this is difficult, honestly, is because in our school administration wants us to have kind of a daily thing where we have a warm up, where there is some kind of content check at the end, and I don't know. It seems like they want to have a formative assessment and a summative assessment. It's a lot to fit into a single class period, honestly. Okay, so now let's put this shape right here. So this is a circle. And we'll make this pink. No, let's stick with our color scheme here. So that's a circle, okay. And we'll see what they think about that. Now here's a limit case. This is the absolute value function. So they need to see this. I don't know that it'll ever be on the STAR test, but they need to see it, honestly. Okay, so V. Oh, so somewhere right here on my actual surface, there must be some kind of issue, like a bubble underneath the screen protector, that's causing that to happen, because it happens every time. See, right there, right there. And then we'll do the absolute value here. Yep, these are good kids. They want to do good, so appreciate them. All right, so here's absolute value. And oops. Well, I want that point to be visible. Let's do this. See, it started in the center. I don't want it to do that. Oh well, it's going to start in the center. And, oh, duh. And this. All right, so this is called an absolute value function. It's not one that I don't think that they've seen before. Okay, it's absolutely a function. But I want to check one thing. So we have to talk about continuous and discrete. That's got to come up next. That's another lesson. I got to make a note of that. Let me check something here. Okay, we don't care about Prince Harry. Okay, here we go. I need to find out. Here we go. Continuous but not differentiable. Okay. So it's continuous but not differentiable. All right. So it, that's funny because you think, oh, the teacher knows it, but we Google it. Okay, is this a function? Okay, so let's take a look at what we got here. We got some good examples. Okay, those are my examples, take it for what it is. So these are my examples. That's the visually. Now, sets of ordered pairs. I mean, this is very similar to the table. Oh, I said I was going to switch these. Okay. All right. This is what I love about OneNote. So, I was going to do this in a separate thing. I mean, second after sets of ordered pairs. So I was able to just move it. That is crazy. That is really, this is where I'm reminded that all this work here on the tablet is worth it when you can just do that. Okay, so this is actually going to be point C, sets of ordered pairs. Is that too close? Needs to be more over. Let's see when Office Depot closes, because somebody said flashcards, and I think that is a great idea. When does Office Depot close? Now they're closed. Darn it. Sets of ordered pairs. Okay. There's really not anything to say here except examples. I mean, okay, I'll just say this. Or analyze, I shouldn't say evaluate. You analyze ordered pairs in the same way that you analyze tables and maps. You analyze ordered pairs in the same way that you analyze tables and maps. It's true. So now we just need to jump right into examples. Well, I should say this. If the x repeats, it's not a function. Oh, you know what? Okay. That reminded me. That we totally forgot to do one graph type that's super important. Why are these all black? I must have tapped something. Darn it. I tapped something and made all of this turn black. Oh, God. Okay. I think I know what I did. When I moved it, I'm not going to be able to recover this, am I? Oh my gosh. Oh man. What a bummer. I have to rewrite all that. But anyway, before I lose my head over that, I'll just do this. This is the 6th example. This is an important one. This is called a step function. Okay, or a step equation, I should say. Example. Is this a function? Okay. And so, you know what, I'll say this. I actually had a student today ask me to teach cursive handwriting. And it made my day because it was a compliment about my handwriting that prompted it. Probably not this handwriting because this looks awful, but my handwriting when I do cursive. She asked if I would spend some time at the end of the year teaching cursive, and that made my day because, I'm a math teacher, and to be asked to kind of integrate the liberal arts, that made me happy. Old-fashioned way. There's some, these kids are traditional. Like we think kids are, like, let me put it this way. Kids will one day become old people, So, anyway, the bottom line is you would be surprised. The kids really enjoyed, I think, writing notes. They liked it. It was crazy. Okay, so here's the deal. Okay, so there's a closed circle and an open circle. Oh, no, I don't want to do that. You put a dot there. Open circle. Open circle. Okay, probably understand where I'm going with this, but maybe not. Oh, I keep doing that. Okay, this is going to be a super confusing one. So now I need to go back up here. Anyway, I'd say that today, the celebration today was I was pleasantly surprised that the kids enjoyed taking the notes. And the classes that went well were the classes where the kids took the most notes. So, I mean, it's surprising to me. I thought they were going to hate it, but they really didn't hate it. I think they appreciated it, that they were kind of felt like they were getting like the old school way, and they like that. So what I'm saying is that students are actually consist. They're not all like super progressive. You know, some of them are extremely traditional people, conservative, and I don't mean politically. I mean like culturally, in how they compose themselves and their value system. They're conservative. And so we don't want to be throwing all this new mumbo jumbo at them, because that's not how they want to learn it the old fashioned way. And I appreciate that. So when you're looking at this one, it's kind of confusing because it's like, what is this? Well, here's what I want to do. I'm going to go ahead and make this a function, and I'll explain why. And this is a super important one, because this, if you can understand this, then you understand the whole thing. Okay? If you can understand why this is a function, then you'll understand the whole thing. So I'm just going to throw a bunch of nonsense in here. Okay. Oops. Is this a function? And let's do this. Okay, so here's the point. These open circles mean that the graph is not defined at that point. That's an open circle. So when you're doing your vertical line test, here I'll just show if anybody's actually watching this. I can't imagine who would be. But when we throw the ruler up there, and this is where this ruler function is really going to come in handy. When we throw the ruler up there and we do the vertical line test, ooh, I better make sure that's actually going to work. Yeah, it's got to be. Just make these points bigger. Okay, so when we do the vertical line test and you put the ruler up there, you say, oh, it's going to fail. It's failing. I need to make the point bigger. It's failing the vertical line test because of this. I can draw a line through it. Okay? Well, that's the wrong reasoning, because look, you say it's going to hit at 2 points, right? That's what you think, but actually it's only defined at one of those points. So, what you're really saying is, yeah, it doesn't pass through. See here, you say, oh, well, and here, in other words, if there were two closed-in dots above one another, then it would fail. But it doesn't fail in this one, so that's a function. That'll be a good one to really get the kids thinking about it. I just can't believe I turned all of those black. That just kills me. It just kills me. Okay. Sets of ordered pairs. Okay, so now we need some examples of ordered pairs. these ordered pairs define a function, and we could say here are the ordered pairs. Three. Okay, we'll see what they do with that. You know what I should say here? A hint would be label each either X or Y. Well, we'll see what they do with that. I mean, just a couple of examples, kind of. Oh, I'm not. Let's see here. I got an idea. Okay, so well, we'll just do another example. I know what I'll do. Make them do some work. One 2/5, comma 1.8. Ooh, I like that. Okay, so square root of 96. So I gotta do the square root of, I gotta do 96. So 96, that's 12 times 8. So that's 3, 2, 2, and then 2, 2, 2. Okay, so So is that 4 square root 6? Let's check that. Okay, 9.79, and now let's try square root 96. Oops. Okay, yep, I did it right. Yay. Okay, so here's what I want to do. I'm going to do this. 0.5 squared. Ooh, that's tempting. Okay. Okay, so we're trying to teach math while we do this, right? Basically. So let's do 0.5 squared. So 0.5 squared equals 1/2 squared. That equals 1 squared over 2 squared. So that's 1/4. Okay, I love this. So here's what we're going to do. We're going to do we need to make this 2 square root 6, so it's not the same. And then I need to have one more coordinate pair. And this will be 0.5 squared. Okay. What the heck? All right. Well, we'll see what they do with that. I like that. Those are challenging. All right. So I did sets of ordered pairs now from a written description and from equations. And when we talk about equations, that's when we need to talk about continuous and discrete. So now I gotta, so then we did visually. Okay, so don't mess this up, bro. Uh-oh. I messed it up. Oh no, I didn't. Okay, so now I've got it reordered correctly. So we do ordered pairs, and then we do visually. Okay? And it's just, I've lost the color. Okay. So we still have to do written descriptions and equations. I feel like we could, so we would say, we'd do sets of ordered pairs, visually from a graph. So sets of ordered pairs are easy. Visually from a graph, that's easy. Those are quick. And then we need to do from equations. And and here's the point I want to make about equations, okay? Oh man, it's all off on the lines. I have to fix that. There we go. Okay. Now, there. I have to add this color back. Okay. And so eventually we're going to do this delta math stuff. These delta math problems are really good because we find f of 3. And so if we put in negative, or f of negative 3, so 5 times negative 3 is negative 15 minus 3. Is it negative 18? So what the answer is. Let's see. Yay. Okay. I love this because it tells you what to do. They're going to start delta math. I wonder if there's any delta math problems about functions. Okay, linear functions. Okay. Determine if a set of points. Okay, here, this is, yes, look at this. All right, so determine if a set of points is a function. All right, which ordered pair does not represent a function? This one. All right. X does not repeat. Oh, I love this. So delta math, this is so cool. You know, the kids are going to love this delta math thing. I love it. I just love it. That's what I'm going to do now. I'm going to hang up here because I have to use student data, right? I've got to go ahead and put all this student data in to get the kids all set up so that we can do that practice tomorrow. So that's what we're going to do tomorrow. We're going to learn very quickly, and then we're going to hit that practice. That's what we're going to do. Let's see. So I can do determine if a graph is a function. Does this graph represent a function? Oh, I didn't show. I'll have to go put, right? Because it's not a function because the vertical line test. I bet they'll be able to get that. Let's see. New problem. Oh, wow. Did you see that thing scanning? Okay, so watch this. Watch this. This is so cool. The kids are going to love this. Watch this thing come in. And boom. It hits a vertical line. So vertical line crosses the graph at more than one time. They are going to love this. Okay. This is a function. Okay. This is a function. All right. It's that easy. Well, let's see. Watch it not be a function. Oh, it is a function. But it's not continuous. Okay. So, okay. This is actually fun. I should assign like 50 of these. This is a function. The kids will go so fast through them, they'll love it. All right, this is fun. I like this. This is not a function. This is a joke. I don't even know what this thing is. It's a square. Okay, not a function. Yay. Okay, they're going to love this. All right. So I am excited about delta math because it's free. Let's see, select equation, function notation with points on a graph, evaluate functions from a graph, blah, 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 blah. Function mapping, let's see if they have the maps. I love it, yes. Okay, so fill in the blanks. The mapping diagram above is not a function since for each number in set A, the input, there are wait a minute. There are multiple mappings to set B, the output. Is that correct? That was actually kind of confusing. What I'm trying to say is 4 repeats. So I actually don't know if I said that right. The mapping diagram does not represent a function. I wish it just stopped there. Since for each number in set A, there are multiple mappings to set B, the output. Now, okay, let's hit it. Here we go. What'd I do wrong? My solution said the mapping diagram does not represent a function. Okay, same here, same here. There is one number in set for each number. Oh, I see. I said for each number, and I should have said for just for one number for 4. Okay, let me try another one. Ugh. All right, so here I've got it. So this is not a function because there is one number in set A, the input. Okay, there are multiple mappings to set B, the output. Now that should be correct. Yes, okay, I understand now. Confusing. I don't like these questions as much. But, you know, because the kids have to choose multiple things, and that was verbally confusing, honestly. So functions graphically, this is super cool. I love it. Wonder piecewise. This is so cool. All right, so I just have to create. I have to create them. Draw a graph from a story. Oh, that's a great one. What does this look like? Connor leaves his house at time 0 right here, and he drives 4 minutes to the store at a speed of 4 blocks per minute. Okay, so he starts here, and 4 blocks every 1 minute. Okay. For 4 minutes. All right, so here we go. 1, 2, 3, 4 over 1. 1, oops. 2, 3, 4 over 1. Well, wait a minute. This should, what I mean to say is, how do I get rid of it? Click twice to plot a line segment. Click a segment to delete it. Okay. What I mean to say is that, okay, here, 1, 2, here, just delete that. So start 1, up 4 over 1, up 4 over 1, up 4 over 1, up 4 over 1, there. Now what am I supposed to draw a graph from a story? Connor is away from home X minutes after he leaves his house until he gets home. Okay, he drove home at a speed of 4 blocks every 3 minutes. So starting there, and then he goes down 4, right? Over 1, 2, 3, down 4. Did I do that right? I don't think I did that right at all. That is super confusing. I don't like that. So he leaves his house at time 0, drives for 4 minutes to the store at a speed of 4 blocks per minute. Okay, I feel like I did that part right. So he's here. He's at 16 blocks at 4 minutes. All right, so now he's going home. He drives 4 blocks every 3 minutes. Well, I mean, okay, so he starts there, and then he goes down 4 blocks every 3 minutes. 1, 2, 3, down 4. Over 1, 2, 3. Over 1, 2, 3. Look, that's what I got. I don't know if that's right or wrong. Let's see. No. Oh, he stopped for 4 minutes. Oh, come on. Come on, I forgot that. I forgot that part. Okay, well, that's actually pretty good. Okay, so it teaches that. You know what? I got to be honest with you. Delta Math, I heard about this randomly and I absolutely love it. You know, if I had something like this when I was a kid, I would have learned so much algebra. It has everything. So I'm just going to set kids to work on this. I love it. Systems of equations, word problems. Wow. This is so cool. This is so cool. Okay. All right. Well, that is where we're going to end this live stream. If you were watching, appreciate it. Y'all have a good night. Thanks.